Hi everyone, I'm Varsha Parthasarathy, Program Manager at Microsoft. I lead growth and adoption of Azure Computer Vision Services. It is great to be here at Data Platform Summit. As I'm presenting, if you have any questions or comments, feel free to put them in the chat window. With that, let's get started. To help set the context, I'll start with an overview of Azure AI and Azure Cognitive Services. We'll go over a broad set of capabilities offered by Computer Vision API, as well as covering key functionalities and a few real-world use cases. At a high level, Azure AI is split into three categories: AML, Azure Machine Learning. This is the training and inference platform for AI ML model development and optimization. On top of this is Azure Cognitive Services. This provides pre-built AI capabilities that can easily be integrated with your existing applications, along with flexibility on customization as well as deployment. Now, the latest addition to the family of AI products is Form Recognizer, Immersive Reader, Bot Services, and other applied AI services. These provide scenario-specific solutions catering to customer needs. Here you can download and get started on right away without any additional knowledge of model optimization, customization, training, or deployment. Now, going deeper into Azure Cognitive Services, this provides developers with a wide range of out-of-box pre-trained intelligent AI capabilities like computer vision, speech. With speech, it's speech to text, text to speech, custom neural voice, etc. With language services, you extract meaning from unstructured text, as well as translation services, and decision services for making smarter decisions, as well as inclusion of reinforcement learning. Now, all of these pre-trained models are trained with Microsoft data. We do not use any of the customer data to train and improve our models. These capabilities are available for developers as REST API endpoints through our client libraries and SDKs, as well as integration to other products within Microsoft umbrella of offerings. And it can be deployed anywhere from cloud to premises, as well as on-premises deployments using containers. Our product includes high-quality pre-trained models with the ability to customize. Pre-trained models make it easy to get started immediately with no data or modeling experience, whereas customization allows developers to bring in their own data, add additional layers to the model to cater to their specific needs. Azure Vision Services offers solutions to both analyze images, documents, files, as well as videos, both recorded and live stream analysis. With these capabilities, the underlying intent for machines is to develop a sense of understanding of visual elements present in images and videos. Image analysis, part of computer vision service, gives you access to advanced algorithms and pre-built capabilities that process images and returns information based on visual features present in the image, whether it is tagging, detecting objects, identifying entities, actions, essentially helping users extract insight from images. The image on the left of the slide, you can see results of image tagger, object detection, image captioning, along with their confidence scores. Tagging provides capability to identify and tag visual features. It could be recognizable objects, scenery, or even actions between entities. And on top of that, detection provides bounding boxes. This helps in creating area of interest and as well as like thumbnail generation, which a lot of our customers use for album creation in digital asset management. Image captioning provides human-readable description based on visual content present in the image. Recently, Microsoft announced reaching human parity, where our research team developed a new training approach tested against the challenging NoCAPS benchmark dataset. The NoCAPS is novel object captioning at scale. It is roughly used as an indicator for advancement in image captioning algorithm. The image that you're seeing right now has been pulled out of NoCAP's test dataset with the caption generated by our AI model. If you look closely, it took me a while to realize that there is a table behind the waffle cone. So it's definitely great to see model picking up these visual elements. Now let's see a few examples of images tested against the previous image captioning AI model, which was released in 2015, and with the latest human parody model. With the image shown here, the previous model provided description, a close-up of a plant, and with the latest human parody model, the caption is much more accurate with a close-up of a wheat in a field. Going into a few more examples, before with the older captioning model, it was a close-up of a person cooking hot dogs on a cutting board, which definitely wasn't accurate. In the latest parody model, you see a person making bread. So it's not just AI model generating captions based on what is present, the objects present in the image, but also the intent behind it. Taking a look at another example, the previous model generated caption, a man in a blue shirt. Human parody model, the caption generated is a few people wearing surgical mask. I do want to call out that we're observing wide adoption of image captioning features as accessibility becomes more essential to aid visually impaired people. Now moving to image tagging. As the pool of digital content continues to grow, the need to organize media and effectively tag photos is also a challenge that grows with it. By using AI, several models can be deployed to classify images in every photo album. The models can then extrapolate the names of people, location, people recognition, any pertinent detail associated with the image, and then matching them to additional filters, which will help narrow down the search results. Let's look into common use cases for image tagging. Start off with discoverability. Most images uploaded to organizational internal share space and social media platforms contain rich information and metadata that is locked away out of sight from benefits such as automated tagging, content categorization, and search. Image analysis definitely allows the insights from these images to be available for analysis, search, and retrieval at a later point in time. And then image content moderation. E-commerce companies have user-generated content. They allow publishers to bring in their own content and upload in social media, whether it's online gaming sites and communities. These definitely need to be moderated to be compliant with online safety regulations. So image analysis allows you to automatically flag inappropriate content, such as nudity, graphic, violence in images, and use metadata returned to apply to downstream processing and business automation. Which brings us to the next use case, which is detecting visual content. You build valuable metadata into the media analysis pipeline. These help both in automating tasks, reducing time and effort, as well as cost associated with content production, content creation process. Moving to domain-specific identification, developers can also use image analysis to identify specific content in social media, whether it's landmark detection or identifying famous celebrities, even brand logos present in images. They provide right recommendation to the engine so you can cater to the user needs better. And the last one, which we did touch upon, is content accessibility, building solutions that help and aid visually impaired readers by detecting visual content in images, as well as providing description in human readable sentences can be done very easily using image analysis. Now let's take a look at examples with previous tagger and the improved model, which is present in the latest computer vision API. Before it was flower, nature, grass, and plant, which are quite generic. And with the latest tagging capabilities, we can now generate more accurate labels and tags. Before it was a person, screenshot, text, generic and probably not very relevant. And with the latest tagger, we have descriptions that are definitely domain specific with an understanding of the area and industry domain. With image tagging, we supported 5 languages: English, Spanish, Japanese, Portuguese, and Chinese in the previous version. With the latest updated model in CVAPI 3.2, we support additional 45 languages, providing support for 50 locales, including French, Italian, German, Korean, and many more. Going into a customer case study for Image Tagger, Media Valley, it's a leading digital asset management company, and they set out to automate metadata production for all of their digital assets to help customers better locate the digital assets and also improve reusability of existing media assets in the company. With Microsoft Azure image tagging service, Media Valley was able to reduce its customer tagging time by months and also improved their tagging accuracy. As a result, customers now have higher asset reuse as well as greater efficiency and increased return on their investment for content creation. Content moderation is another popular service with computer vision offerings where Content Detection API flags images containing explicit content, whether it's sexual, offensive, violent, gory visual content present in images. There are a lot of improvements we have done based on user feedback in both workplace as well as virtual classroom use cases, which has definitely seen a spike in image content sharing, like memes, animated cartoon pictures, instructional materials with highlights. And enterprises are using this capability to moderate images shared in chat rooms, message boards, email threads within the organization to deliver safe content to their users. And on the slide, you can see a few images with the previous model were tagged as adult content. And with the improvements we've made to the adult content model, these are no longer tagged or flagged for adult content. Here I'm sharing an example of one of Microsoft apps using Content Moderation API to detect and flag adult content in Outlook, Teams, Skype for Business, and Yammer chat rooms. So once you create and configure using the categories of images you want to flag, whether adult, racy, or gory, and go through the images in the chat boards, in the Outlook emails, as well as Teams messages, and admin gets access to all the flagged content for review and taking actions downstream after. Let's move on to video analysis. Here we'll walk through our latest offering, spatial analysis, that draws AI insights from real-world applications to improve customer experiences, safety, and productivity. Spatial analysis runs Vision AI on live and recorded video streams to understand people's movement in physical spaces. We offer solutions for people counting, social distancing, monitoring people entering and exiting physical spaces, and all of these offerings are currently in preview. Spatial analysis provides features to help build solutions for occupancy management, enforcing social distancing, as well as optimizing in-store office layouts to help with checkout process. Now let's go through each of the operations and how it can help our customers. With people counting, this helps monitor and alert for maximum occupancy by counting people in a designated area. Here, users can collect historical data and make decisions for how to optimize the occupancy for physical spaces. The second use case is something that is top of mind these days, which is social distancing. In this case, instead of people counting, we're running social distancing operation. And notice that with a single camera, you can run both operations, both detection and social distancing. And for the purposes of this demo, we're running both on the same video feed. With social distancing, you can set a minimum required distance between people, and by saving these AI insights, you can also create historical reports to determine trends in pandemic compliance. In this demo, you can see how retailers can determine wait times at a checkout queue. We drew a polygon around the checkout stand, and as people enter the polygon, we start the timer and then stop the timer when the person exits the polygon. And by looking at number of timestamps of these events, we determine the time spent by a person at the checkout line. This AI operation can be used to monitor entryways for traffic as well as maintaining optimal occupancy while detecting when people are entering and leaving a particular zone. In addition, we're also providing face mask detection capability that is available in Cognitive Services Face API, as well as spatial analysis for both people counting as well as people crossing lines in zone. Here's an example of an employee entering one of the offices where we're detecting person as well as whether the employee is wearing a mask or not. This helps with face mask compliance that a lot of retail stores as well as commercial buildings are required to maintain for the safety of their employees and customers. I'll provide more info on deploying spatial analysis container on your edge premises. Step 1, you need an edge device with NVIDIA T4 GPU. We have tested spatial analysis exhaustively on Azure Stack Edge that usually contains 2 GPU units, which you can also order through Azure portal. But this works on any Stack Edge device as long as it has at least one NVIDIA T4 GPU. So deployment needs to be configured using Azure IoT Hub. You need to create an instance of IoT Hub service, register the edge device, and the deployment manifest needs to be changed into an IoT module. For camera devices, you need to install these in a physical space following manufacturer's instruction. And since these cameras are IP connected, you need to make sure that the edge device can connect to these cameras over RTSP protocol. Once the spatial analysis container is configured with the cameras and the RTSP URL, AI insights about people's movement along with confidence scores will be sent into Azure IoT Hub into IoT telemetry. And from IoT Hub, you can create various routes to other Azure services to build your business solutions. Let's look into specific use cases of where this could be deployed. One such vertical is manufacturing, where plants need to monitor zones where people's presence is not recommended due to safety concerns or it's an accidental area. With spatial analysis, AI running on videos from cameras can detect people in forbidden zones in real time and notify the administrations or safety personnel in that area to vacate the employees involved to avoid potential danger using our alerting features. And in retail industries, retailers need to better understand how customers move through the store, how to modify the store layout for maximum revenue. They do want to measure how much people spend time in a line or in front of a retail display. So store layout helps people maintain social distance as well. With spatial analysis, you can build your own solution for retail industry, improve customer satisfaction, increasing revenue. This feature is also available through Dynamics Connected Store, which is a SaaS offering with specific customization for retail customers. That brings us to the end of the session. I hope this information was useful to start infusing AI into your business applications. I'm also sharing a few links on the slide to get started with Azure Cognitive Services Portal, as well as links to documentation, tutorial, quick start guides to get started. Thank you for joining us at this year's Data Platform Summit. If you have questions, comments, please drop them in the chat or reach out to me directly on Twitter or LinkedIn.